Hi there. Let me go through question 3.56 with you. The biggest mistake on this question before you do anything is to make sure that you have your lists in the right place in your calculator. We're trying to build a model where we're using the US percentage returns to predict the overseas percentage returns. So this is the explanatory variable. They have listed the list for the X's second. This is the response variable. This is the list for the Y's. So it's important that you get them into your calculator in the correct order. The explanatory variable or the X list is US. The response variable or the Y list, that is overseas. That's the most common mistake on this question. So to the graphing calculator then, I have made sure that I've done that correctly. If I go to stat and then to enter, if I look at the data, the 14.6, that is the first percentage return for the US, and this is the corresponding overseas return, the 29.6. So I have them in the right order in my calculator. I'll press zoom 9 then in order to create the scatter plot. That's what you're asked to do for part A. So notice the scatter plot has a lot of variability in it. There's a positive direction here. It's somewhat linear in form. We could fit a best fit line through that, but there's going to be quite a bit of variability there, so it's not a particularly strong relationship, and we'll see that in part B when we interpret R and when we interpret R squared. So to calculate R and R squared, we'll go to stat, calculate, we'll choose option number 8. So again, we have to have US returns in list 1. We have to have overseas returns in list 2. And we'll calculate this. So the correlation is 0.464, not particularly strong, and R squared is 0.215. That's relatively low. And in part B, you are asked to describe the relationship between US and overseas returns by using R and by using R squared. When you write about R and when you write about R squared, you write in very different ways, so it's important to take a look at that specifically. So here are the values. So R is 0.464. The correlation describes the strength of the linear relationship. So that correlation means that we have a relatively weak, we have a positive, but relatively weak linear relationship between US returns and overseas returns. So the correlation describes the strength of the linear relationship. The closer the correlation is to 1, the stronger the relationship. The closer it is to 0, the weaker the relationship. And like we saw in the scatter plot, the correlation is positive, so that indicates that the linear relationship does rise from left to right. So the interpretation of R squared, though, is very different. This has a lot more to do with the specific linear regression model that we have built. 0.215 says that 21.5% of the variability or the variation, and we're talking about the variation in the response variable, that is the overseas returns. So 21.5% of the variation in overseas returns is explained by the straight line relationship or by the linear model. I tend to write by the linear regression. By the linear regression on the explanatory variable. The explanatory variable is US returns. So we're not explaining very much of the variability in Y. We are only explaining a little over a fifth of the variation in overseas returns by using this linear model. So it's not a particularly strong model. It's not a particularly useful model. So in part C, you're being asked to write down that model specifically. So let's go back to the linear regression. I can see that my slope is 0.62 and my intercept is 5.69. So I will write it down here. The intercept was 5.69 and the slope was 0.62. So we'll switch back to the document camera. So here is the model, intercept, slope, where we have to define the explanatory and the response variable. It's also important that you have a hat on the response variable. So X is US returns, and Y represents overseas returns. It is important that you have a hat on Y. The hat on Y indicates that you are making a prediction, so that's particularly important. You're asked to draw the line on the scatter plot, so we can do that on the calculator just by putting it into the Y equals menu. So I'll go into Y1 and I'll just type in the 5.69 plus the 0.62x, and we will see that best fit line go through essentially the middle, if you will, of the scatter plot. Again, you can see there's a lot of variation below and above that best fit line, so it's not a particularly good fit. So the last part of the question in part D is asking you to make a prediction and tell what you think about that prediction. So in that question, in 1997, according to the table, US stock returns 33.4% return. That's quite a bit of return. Use the line to predict returns on overseas stocks. So fine, my prediction would be 5.69 plus 0.62 times the US percentage return, which was 33.4%. So we'll put that into the calculator. Go back to the home screen. So 5.69 plus the 0.62 times my US return percentage of 33.4, that gives me a prediction of 26.4% for overseas returns, 26.4%. So my predicted overseas return, 26.4% for overseas. So, and it's approximately. The approximate or the estimated overseas returns. So, and it is good to show your work, as simple as this work is, show what you're substituting into the model in order to get your prediction. Now notice the actual overseas return was 2.1%. Are you confident in general then that this regression line is going to give you accurate predictions? So the answer is no. I don't have a whole lot of confidence in this regression line. So the first thing to notice is this residual is huge. The residual, remember, is the actual value of Y, take away the predicted value of Y. So in this case, the actual value of Y was 2.1. The predicted value was 33.4. So that residual is huge. 2.1 minus 33.4. That gives you a residual of negative 31.3. This is an overprediction by 31.3. That's a pretty large overprediction there. That is certainly a large residual, negative 31.3. That doesn't give me a lot of confidence in this model. So that's the first reason why I wouldn't have a lot of confidence in general with the accuracy of this model. Second, another reason why I don't have a lot of confidence in the predictions this model is going to make is because of the value of R squared. In general, this linear model is only capturing 21.5%. We're only explaining 21.5% of the variability in overseas returns by just using this linear model on US returns. Almost 4/5 of the variability we see in overseas returns can't be predicted by this model and is influenced by other values that we're not accounting for. So again, that really doesn't give me much confidence that this model in general is going to give me accurate predictions. The other thing that you could do is take a look at the residual plot. So if I go into plot number 1, the last regression that I ran was for this model. So the residuals for this model are stored. I'll put that into my Y list, second stat, and I'll go down to the resid list, which is automatically stored, and press enter. So I'll zoom 9 this. So these are the residuals for this model. That is the best fit line. I'll just turn it off by highlighting the equal sign and pressing enter. So this is the residual plot. And I'll tell you what, the residuals are nicely scattered. When I look at that residual plot, you might tend to think, oh, well, that's a scattered residual plot. I don't see a pattern there. That suggests that my model is a good fit. Well, the model isn't necessarily a good fit, really, because the value of r squared is also quite low. Something to think about here, if you trace these residuals are very large. There's a residual of 14.85%. Here's a residual of 18.8%. Here's a residual of negative 11.4%. Compared to the magnitude of the values of x and y, these residuals are very large. And even though they're scattered then, what that means is there are very large prediction errors here. That's what we see in this residual plot. Even though it's scattered, the actual values of the residuals are so large that, again, it doesn't give me a lot of confidence that in general, this linear model is going to give me accurate predictions. And that's what part D is all about. Hope this has been helpful.